Okay, welcome back. Alright, so I have managed to find it. So I think the error due to the link library because we can see here. Okay, it's mentioned here the link and also target library does not contain all required gates. So this is because if you see in our manual, okay, we have set this, okay, SC max DB, IO max, RAM, and so on. So, but we need to set another two, I think. So we have set this one, these three, okay, one SC max, IO max, and RAM. I need to set the other two, target library and also symbol library. So to do it, I believe we have to, go back to the setting, okay, under the previous tab, which is we actually missed this step lah, step number 5. We see step number 5 if you see it clearly. So we need to assign all the first three link library together, and then followed by the target library, scmac, and also scdb, sdb. Okay, to do it, okay, we will do it together. Okay, don't worry about this, and I'm sorry because I'm not sure this is intentionally happen or unintentionally. Maybe if this happen, it will give every one of us experience when you get the error and then why. Okay, the most important thing is don't miss the step lah. Okay, maybe I miss a step, even me as your lecturer also miss a step. Okay, so we go back to the, I think, this one. Okay, step number 3, file setup, application setup. Okay, file, maybe I make it bigger. So file, setup, and then application setup. So see, we have all this actually. Okay, but all of these need to be under link library. Okay, not under target and symbol library. So to do it, you remove this. Delete this first. Okay, and then remove this. Okay, and then under the link library, what you need to do, you need to add additional 2 file, which is your, I bring it here again. Okay, your IO max, RAM, and also SC max. Okay, as mentioned here. Okay, SC max, IO max, and RAM. So IO max we have already have it, I think. Double check. Oh, SC max we have it already. So SC max finish, IO max. Okay, open IO max, and another one sc.sdb. sc.sdb, which is this one. And then you click OK. All of this will be under the link library, and then for the target library, you browse for location of sc underscore max, sc underscore max db. Okay, sometimes warning and errors also important lah. So keep monitoring the progress. sc max underscore db, sc underscore max db. Sorry. Okay, and then you okay, and then symbol library scsdb. Okay, this one open, and you okay for it. So everything is in order. Okay, so let's say we try click OK this time and see whether our history have that step or not. Okay, same. It's not reporting any step, but it's okay. Okay, you go double check setup, application setup, as long as all the file located as expected, and then it's okay. Okay, now what we need to do, we go to the I think we already set the TLU. Okay, we try to skip step number 6 because we already set it, and then we have already located all the timing information, import the design as well. We have done it. Okay, what we do, we try to place, okay, the last step that we have missed, we have problem. So this step we okay, we have that. Okay, here is actually the step, place our design. Okay, okay, to do it, I think we make it side by side so that we can see it clearly. Okay, and then again we try to see the history, place again. So PLACE and OPT. Okay. Hopefully we get all the rectangular move to the, okay, finally. Okay, all right. Okay, now happy, yeah? Everyone happy. So now we can check this, zoom this. Again, we use the window button again. Click on this and see all the logic mapped inside the core area, and then we can see it clearly lah. So all actually are all of the logic elements lah. Okay, inside it's actually do a placement inside the core area, our chip core area. Okay, our chip core area, as mentioned just now, all area under the internal square or internal blocks inside your power supply, okay, and also your VSS. Okay, all right. After finish that step, maybe I bring it back here. Okay, so we can see clearly all the elements, okay, of the multiplier. Okay, at this point we should probably change the visibility of the metal layer of the standard cell. Okay, make sure to check pin and hit apply. So we have pin here. Okay, we tick on it and then we click apply here to see the visibility of the pin. Okay, okay, should be able to change the visibility of metal layer. We want to see it. Okay, of the standard cell pins. Okay, to do it, okay, okay, you go to this one. Okay, maybe I make it bigger. I move my face here. So you go to pin and then you tick on this. Okay, and then you click apply, and then you should be able to see the changes here. All the pins here. And then you can even zoom it and see all the pins labeled as I here. Okay, all of these are a pin. Okay, I believe this input output pin of the internal logic. Okay, I, we can see I and O here and then I. Okay, it mention, tell you about the detail when you click on it. Okay, see, all right. Okay, and then we scroll it, we zoom it back, and then we, okay, make it side by side. I think we need to press window button again, okay, to make the cursor active. Okay, we have done that step. Okay, we have done this step. Okay, then we see it clearly. Okay, the pin, and then what's next? We're adding or and connect the power strip. So means that we connect our power, okay, to the internal logic. Okay, because the logic gate inside the core area also need that power. Okay, now we need to connect the power rail for the standard cell inside our core area. Okay, so this is our chip or our die, and then we have the I/O port for the outside, and then we have the we have the VDD and VSS, the ground, and this is actually the core area as I mentioned to you. So we have all the standard cell inside this. Okay, to do that, to do the connection of the power to the standard cell, okay, inside the core area, we can either do using this step, pull down menu, pre-route and pre-route standard cell, or using ICC shell command, sorry. So we will do using ICC shell command. Okay. So first we need to have the command comment, confuse command and comment. Comment it first so that we can easily trace it, and then we put the all the command, and then you enter. Okay, and always check if there is any error. Okay, warning is okay, just for your information, but this might be useful for you when you encounter something lah. Okay, something abnormal in your lab. Okay, so far it's still okay. IBM is there. All right, so it's okay. And then what's next? We see the lab manual. So clock tree synthesis. So we will do a clock tree synthesis. So clock tree synthesis, actually, we have our clock main source in the outer side of our core area. Okay. So every standard cell that has a clock element, so inside our standard cell that has a clock element, they need to have a clock source connected, okay, from the main source to the standard cell element. Okay. So to make sure that we have we can reduce the what we call a clock skew. Okay, they're different in the clock arrival time, so we need to have a clock tree synthesis. We need to perform it. Okay, to do it, okay, we can go to the GUI using a pull down menu. Okay, CTS and optimization, or we just type this. Okay, clock underscore OPT, like place just now, place underscore OPT, place optimization, okay, whereby we put all the standard cell inside the core area. So place underscore OPT, and this time we do the clock underscore OPT, okay, to perform a clock tree synthesis. Okay, let's go to the practical. So to do it, remember always this is actually a good practice to have a comment, okay, in your works. So clock tree synthesis, and then clock optimization. So you just type, okay, CLOCK underscore OPT, and then you look at here. It will give effect to your chip, if I'm not mistaken. Yeah, you see the red color here. Okay, this is actually the line of the clock from the main clock source here. This is actually the main clock source here, and then it supplies inside throughout across the chip. Okay, okay, this is actually the line. Okay, we have three spine here, main spine here of the clock, and then it will distribute across the chip area in the core area. So to look inside, maybe I double click this, and then we can zoom it. Okay, so clearly we can see the clock tree. Okay, this is what we call as clock tree, like a tree. Okay, and then this is how they distribute the clock. And if you zoom closer, you can see this is a clock port for the particular logic. Okay, okay. Similarly for the rest. Okay, the main clock source is actually here. From here, it goes to the rest. Okay, or inside the chip. Okay, so hopefully everyone can see it clearly and can relate it to the lecture. All right, so we have done that part. So what's next? We check the timing. To check the timing, similarly, we report underscore clock 3 underscore 3 and then report timing. Okay, similarly, always have the command written here. So need to press the window button again to make it active. Okay, and then check the timing. Then you report up, and then you can see the what we call information. Okay, report clock 3. So what is actually R stand here is actually R here stand for rising. If you see F is falling, R here rising. Detail you can get it online from the Synopsys manual. Okay, Synopsys ICC manual or design compiler manual. Okay, so it reported here all the information Okay, fan out and so on. All right. can explore this detail, okay, later on. And then the next we do a report timing here, and then report timing, and then it will tell you about the timing report. Okay, here we see you see the F and also R. So R stands for rising, F stands for falling edge of the clock. Okay, remember, if you forgot, maybe I can explain here. Okay, so this is your clock. Okay, not your ideal clock. This is actually the actual clock. We have the slope here. Okay, so this is rising, so R, and this is falling. Okay, of your clock. Okay, and then what it tells you? So it gives you the clock network delay. Okay, it's 2 unit. So normally the unit is in nanosecond lah normally. Okay, and then it also tells you about the data required time, data arrival time, and also the slack time. So here we see the slack time is positive, means that the data required time, the data arrival time is faster than your required time. Means that your system work faster lah, your design work faster than your target. Okay, because you target it to 40, if I'm not mistaken. Yeah, your clock period you set it to 40. Remember your design vision, that one. Okay, you set it to 40. Okay, but it depends on your design lah. If you set to 20, for example, and then it will report 20 lah. In this case, it's 40. Okay, and you minus the other delay lah, 1.65, the output external delay and so on, and then your total time is actually 38.65 required time for the clock. But you manage to for the design, you manage to do it only 2.64 time unit. Is that the difference is positive? That's actually the slack time. You can further optimize your design. Okay, for further test it, you give it to lower higher clock frequency, for example 20, and then you should be able to see it still met lah the time specified. This is actually done in your lab number 2. Sorry, lab number 1. Okay, so what's next? So detail you can Google lah, and check it on the manual as well to understand. So we have done the report timing, and we will do a routing. Okay, for routing, you go to core routing and optimization. Okay, we do the actually a wiring lah. Okay, inside the standard cell. Okay, or alternatively you do the step using IC shell. Okay, we do using IC shell. First, as usual, you set the you write the command. Okay, and then after that you enter the command. Tell the IC compiler what to do. You do the routing. Effort is high, means that you maximum effort. It will take some time because you put high, it will maybe requires more time compared to medium or low. Okay, all right. So you can see the changes here is to the routing. Okay, and also it mentioned you here no violation in terms of DRC. Okay, route violation also none. Okay, everything is okay, fine. Right, so you can zoom in, okay, to see it clearly lah. So what happened in terms of interconnection? So now instead of only you having clock, okay, I think this is clock lah, if I'm not mistaken. Okay, yeah, clock. We also have other interconnection. Okay, for connecting all the standard cell inside our chip. Okay, now it's become more interesting. All right. Okay. All right. So we have done that part. After core routing and optimization, so we can see same as ours. Okay, this is just a repetition of that diagram. And then this is actually the information from the report, from the log. Okay, now we do the DRC LVS. Okay, DRC LVS is very important for us to perform design rule check. Okay, on the whether our design follows the rule or not in terms of the layout of the transistors, and also LVS actually layout versus schematic lah. We have the schematic, okay, of the multiplier, for example, and then we have the layout. So we compare whether the layout and also the schematic are the same or not. Okay, right. To do that, we have several options. Okay. So we can use the ICC shell here. Okay, ICC shell here by typing this command. Okay, right, to do it. So let's start. So we put the what we call comment first. So you can also always check the history lah. So we have so far 32 steps of the history. Then again, press the window button to make it active, and then you add here. Okay, information we are going to perform the RC error check. Okay, and then we perform the copy, and then we perform the, I think we copy all and then we delete the slash. It's easy. Okay, delete the slash. Don't forget the white space. Try to understand what is actually this instruction. Tell the compiler or the ICC. Okay, then we enter. Oh, I think we have finished. Enter. Why? Looks like we have another interesting challenge. It is. Try window button again. Then we paste. Then we enter. Looks like one. I don't know why. Oh, okay. We forgot this. Then we enter. Semicolon. Not semicolon. Double quote. Okay. And then you can read the report lah. Okay, read all the report. We have warning and so on lah, and about the DRC. Okay, and then I think we also have errors here, but don't worry about it. We have the DRC summary. Okay, we can read this and try to relate to your design lah. Okay, remember you can also refer to the textbook and check the design rule specification. Okay, in terms of violation, total violation is mentioned 34 here. Okay, and also tells you about this is actually the first violation lah. Okay, and then it will do the repair, perform the repair until no violation. Okay, and did adjustment for you lah. Okay, the process of floor planning, place and optimization, and then now you do the DRC, and then the system will automatically fix for you from the total of 34 errors. Now it's back to zero, become zero violations. Okay, so you can investigate this before and after for your report. Okay, and then what's next? Okay, we see the next step is actually check or fix the LVS error. So we copy this. Okay, and then we will do these two steps. Okay. Okay, this is a command. Okay, for us to check our report easily, and then we have all the step instruction. Okay, try to understand what actually it's all about. Extra positional option, verify LVS, so it tells you and so on. Okay, we make it bigger. I think we check on the command first. Should be okay. Okay, don't worry about that error. Hopefully didn't give you a big issue. Okay, now we go to the next step. Okay, History is recorded. Okay. We go to the next step, which is okay. We add the filler cell. Okay, we add the filler cell. Okay, and then until I think we are almost finished. Yeah. Okay, we add the filler cell. We try to add it. We put the comment first. Okay, add the filler cell. Okay, and then we follow here whatever the step there, but try to understand. So please remove the what we call slash. All the slash you need to remove it, or you copy one by one and then you paste it. Okay, either way. Make sure not to accidentally delete all the one of the words. Now let's perform it. Okay, filler cell insertion, you can exploit by your own. Okay, and then we do the connect any stray power net. Okay, we do that one. It's actually the step now. Okay, just follow the step. Okay, and then for each net we set this one. Okay, and then that one is for VDD, and now we do for VSS. Okay, it's okay. Then we do the DRC LVS check. Okay, all right. Okay, we go to DRC. Okay, put in here and enter just a comment. Then we verify our DRC. Okay. Problem with command or no? Verify underscore DRC. There is no understand the command. We verify underscore DRC. Verify underscore DRC. Okay. Maybe you can skip it first. Don't worry. Verify LBS. LBS, okay. Okay. Verify DRC. I don't know. It's not okay. Try again. Verify underscore DRC. Yeah, we cannot use it. We use LBS. It's okay. Okay, it's okay. You just keep that one. And then stream out the GDS file. Okay, now we are creating the GDS file. Okay, if you go to your step at the beginning here, we are about to do a tape out lah. So we perform the verification. Then now we will do the save our GDS file. Okay, you can do it by file export write stream, or you can also use this method. Okay, so to do the DRC, alternatively, I think we can do it from the pull down menu here. Okay, but I try to explore verification. So under verification, LBS, we have it here. DRC, verification DRC. Oh, we didn't see it. We didn't have the DRC in this version. DRC verification. Okay. Maybe sign off DRC. This one. Okay, it's okay. You just keep this one because we don't found in under verification. If you want to try it, it's okay. Proceed. Okay, but for this demo, I just keep it because LVS. Okay, all right. And then the next one we do the GDS file export and write stream. Okay, or can use the command here. Okay, we use the command. Okay, then and then we make it smaller. Then back to this one. That one. Add your design. Okay, add your design and set right. And then don't forget to remove the slash. And then enter. We have set it, and then we write stream and name the file as multiplier.gds. Okay. 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 Then you enter. Don't worry about warning. Okay, it's everything is okay. So our GDS file has been successfully completed. Okay, I think that's actually we have finished it. Okay, we have come to the end of the lab. Okay, finally. Okay, and then this is actually the appendix that I share with you all. Maybe some student got problem with um, to reload your design and so on. So this is actually the step for you to follow. Very important, very good one. Okay, maybe that actually will be helpful, hopefully, for everyone. Maybe you want to reload your design after you come back from um, a break or whatever. Then you can use this appendix and hopefully it's helpful for everyone. So this lab manual I already upload in your actually Google Classroom. Okay, you may refer it. Okay, and then if you go to your classroom, okay, to your classroom, I already upload it. Okay, which is this one. I think together with the all of information is in here. Okay, you may refer this, and then I will also share this video in my YouTube. Okay. Okay, for those who not subscribed yet, please do so because you will get the notification when you subscribe and click the bell button, and then you will get the notification. Right. Okay, and then once you finish that, remember your lab number 1 and number 0 and number 2, you need to upload the what we call the log file, okay, of your software, Synopsys Design Compiler, and for lab number 2 is design ICC. Okay, so just click this one. All right, for some time, and then you upload the log file. So the log file you can copy from your so this is actually the interface just now. You write all of this detail, and then you upload your log file. So for design vision and also for your IC compiler. So for this lab IC compiler lah. So you actually copy all the log file and then paste in Notepad, for example, and then you save it and then you upload. Okay, so each of the group member, remember, each of the group member, okay, by all students. So this serves as attendance for your lab. If you submit report but attendance is not there, then the report will not be considered. So please not. So once we finish this, okay, this is actually the log file. You can copy this. You select all and then you copy it, and then you open Notepad. Okay, and then you paste and then you save it. You save it in your folder. For example, I just put in under maybe under this subject. Okay, and then maybe lab 2 design ICC. Just give any name lah. Okay, you close it, and then you upload it. Okay, in here lah. Upload in here. Okay, all right. Okay, for history is optional. If you like to copy it, you just select all, then you copy it, and then you maybe put on under the same file at the end of that file lah. Okay, notepad file. I forgot where I put it. Maybe I open it again. Open it, I think under this one, yeah. Okay, this is your ICC. Maybe you can maybe put early lah. Put dash here just to separate it. These are the steps. And we tag the beginning. Then you save it. Okay. Hope it helped you. Okay, and then once you have finished, you just type exit lah. You can print screen your result. Okay, your waveform, your not to say waveform, your layout. Okay, sorry. You can print screen this. Okay, and then put inside your report. Okay. Then to close it, you just close that one, and this one as well, and then you can type exit lah. And then this will exit for you. You can okay, you can save it as well. Save all. Okay, so finish, and then now you can see in your see where is your current working directory. Okay, and then you can see your file, whether we have the GDS file or not. So now we have the GDS file. We already have the GDS multiplier.gds. Means your lab has successfully finished. Okay, and then you can exit. Okay, and then you can close everything here, and then you can log off. Okay, use the window button, and then you log off. Okay, I think that's all for now. Hope this helpful for everyone. Please settle your lab number 2 as soon as possible. Okay, thank you and good luck.